Now the two rules we're going to be looking at today is the zero index, which is actually very easy, and the power of a power. Now, the zero index indicates that anything to the power of 0 always equals 1. It doesn't matter what it is. It can be 9 to the power of 0, it will equal 1. It can be x to the power of 0, it will equal 1. It could be a very large number, so let's say 99999 to the power of 0 will equal 1. And we can test this on our calculator. Let's say 99999 to the power of 0 equals 1. Okay, no matter what number to the power of 0, it will always equal 1, no matter what. Okay, that's our first rule. And the second, the power of a power. Now, if we have x to the power of 4, that's a power. Okay, that's the power, the index. If we're putting this into brackets, and then we're going to do some other kind of power on the outside, let's say 2. Okay, so we have x to the power of 4 inside a bracket to the power of 2. To expand this, like we were doing with expansion before, we're going to go 2 times 4. So this is multiplied, not plus like we did before. So we're multiplying here. So x, 4 times 2, gives x to the power of 8. Okay, and we can do this with any number. Let's say we have 3 to the power of 4. Oh, no, another number. We just did that. 3 to the 5 to the power of 3. Okay, so we're going to times these two little numbers. Our base will be the same. 5 times 3 will be 15. Okay, that's the two skills we're learning today. Very easy. So I'm not going to go into too much depth about this because this is a pretty easy rule. The other one with the zero index, I will say, is that you can have something to the power of 0 and also other parts of it not be parts of the 0. So if I was to give an example, 2m to the power of 0. So with this example, what if we're breaking this apart? This is 2 times m to the power of 0. This m part to the power of 0 would equal 1. So we could say 2 times 1, which equals 2. But if we will look at this first example, if you say, oh, anything to the power of 0 equals 1, that is true, but this coefficient is separate. This is 2 times 1. This whole thing doesn't equal 1. Okay? So it does not equal 1. You actually have to compute it. Break it up separately. This part equals 1. 2 times 1 equals 2. So, let's do this, and we can have our calculator handy. All you want to do is start inputting these values. So we've got 2 to the power of 6. Let's just double text that. Yep, that equals 64. 2 to the power of 5. Yes, equals 32. 2 to the power of 4 equals 16. 2 to the power of 3 equals 8. 2 to the power of 2, 4. 2 to the power of 1 just equals 2. And 2 to the power of 0 equals 1. So you can actually see a pattern here. It's halving every single time. It's going down. You just need a calculator handy to help you with these. Okay, find each of the following. I'm going to be honest, all of them are going to equal 1. But let's just show you. 6 to the power of 0 equals 1. 21 to the power of 0 equals 1. 582 to the power of 0 equals 1. And 3.7 to the power of 0 equals 1. So again, just demonstrating that anything to the power of 0 just equals 1. Okay, simplify each of the following, leave your answers in index form. So this is the multiplying power of a power. We are still going to write the same base. But here we're going to go 6 times 2 because these brackets mean multiply. So 6 times 2, that is going to be 12. So y to the power of 12. Our base will be the same, m. 3 times 6, well that's 18. So we have the power of 18. Do a different color. 3 is going to be our base. Let's write that just down here. We're running out of room. 3 is our base, and we have 2 times 3, well that's 6. This is going to be 4, which is our base, 3 times 5 to the power of 15. Now, this one is a little bit confusing because we have these numbers out the front. Well, we're going to multiply them separately. So let's just quickly just do this. 5 times m8 to the power of 2. So let's break it apart and we'll bring back that 5. So it's like a workshop in some way where we can split apart our number, work on this little bit, and then bring it back to the whole. Okay, so it's kind of like pulling a motor out of a car or separating some whole unit, working on a little portion, and then bringing it back to that whole. So here, we're going to be working on this section here. So m to the power of 8 times 2. So 8 times 2 gives us 16. So it's 5 times m16. And then we can put that back together. 5m16. And that's our answer. So we're just focusing on this part and computing this part by separating them, and then we bring it back together. This one, 4 times q7 to the power of 4. So let's do this part first. 7 times 4. Oh, I think it's 28. Let's just double check. Yes, it is. And then we bring it back together. Okay. Now, these ones I think are probably the hardest ones. So when we're doing powers on powers, anything that's inside this bracket is going to have the power of 2. So we're going to put this 2 to the 3 and this 2 to the x as well. So what this actually becomes is not just 3x squared, but becomes 3 squared x squared. So that 2 gets multiplied to both of them. With this one, the 4 is going to multiply with that 3 on the x, and it's going to go on the 2. So the 2 to the power of 4, and x, 3 times 4 will give us 12. And lastly, 6 times 4, and 6 times 2. So 6 times 4 is 24, so x 24, and then y 12. So those are probably hardest because you need to put the index on every single new number in or digit inside the brackets.